Well, thanks for being here. We have, what are you going to talk about? Uh, can you give a sneak peek?
Yeah,
Yeah,
sure. So, go ahead,
I
Jason.
I can take it. Sure. Yeah. So today we're going to talk about Java EE and some of the locations where you can run that on Azure.
All right.
Take
So,
those customers who are already in production. Josh was mentioning getting to production. They're already in production. Now they want to make it faster and cheaper and better.
okay. So talking about existing Java EE applications. I mean, Josh spoke about creating new applications, start on Spring.io. I don't think there is like migrate.java.ee kind of website, right? It's something that requires a little bit more, but that's where you're gonna show how can be done, right, with
Yep.
existing technologies and Azure services. All right, so we are on time. So thanks for being here, and yeah, you can get started.
Okay, great. So hi, everyone. Thanks for joining today. My name's Jason Freeberg. I'm a product manager on Azure App Service. And today I have the pleasure of being joined by James Faulkner, Director of Product Marketing at Red Hat. And in today's session, like we mentioned, we're going to talk about migrating and modernizing your Java EE applications with Red Hat JBoss EAP on top of Azure App Service. So if you have any questions, feel free to post those in the chat as we're going through this. But without further ado, let's talk about Azure. So as you might assume, there are a lot of options for hosting and running your Java applications on Azure, and it all depends on where you want to land on the control to productivity spectrum here. So of course, Azure has infrastructure as a service. You can use virtual machines on Azure or virtual machine scale sets to host your Java applications. And if you're not familiar with that term, virtual machine scale sets, that service is a infrastructure as a service offering that allows you to scale your applications out to thousands of VMs. But as we all probably know, virtual machines and raw infrastructure comes with its own level of management and configuration versus some other options out there. So if your organization uses containers, you can use a service like Azure Kubernetes Service or the joint service Azure Red Hat OpenShift. And in both of these cases, it'll provide a few more productivity features to allow your organization to achieve more and probably get to production a little bit more quickly. Now, going even further up into the right, if your organization does not want to be in the business of managing virtual machines or in the business of orchestrating containers, there are services like Azure App Service, which we'll be talking about today in this session. And there's also Azure Spring Cloud, which Josh Long just mentioned in his session. And both of these services provide a managed platform for deploying your application code or containers. So in today's session, let's take a closer look at Azure App Service, and let's start with deploying, because deploying your application code is often the first step in trying out a new compute service. So like I mentioned, with App Service, you have the option of deploying your application code, or you can also choose a container. So if you're deploying your application code, that will go on to a container image that Azure App Service will manage and update for you. But if you're already using containers and you have a registry, you can simply point to the container image and then App Service will pull it down and run it just the same as if it was a managed image on the platform. So for deploying code, App Service provides APIs, plugins, and extensions to deploy from a whole host of client tools like you're seeing here. We have plugins for Maven, Gradle, GitHub Actions, Jenkins, Azure DevOps, and probably more that I'm forgetting. And so you can use those tools to set up a CI/CD pipeline to continuously deploy to Azure App Service. If you go to the Azure portal, you can go to the Deployment Center, and then from there, App Service will help you set up a CI/CD pipeline from GitHub or Azure repos. On the other hand, if you already have a CI/CD pipeline and you want to continue using that system, then you can use tools like the Azure CLI or the Maven and Gradle plugins, and you can use those tools to deploy as part of your existing pipeline. Now, once you've deployed your code onto Azure App Service, there's a feature called deployment slots. Now, this feature is essentially independent staging environments where you can deploy a new version of your application, or you can test new configuration changes. You can deploy pull requests there. You can also use it as a QA environment, things like that. And when you're ready to put that new build of your application into production, or if the new configuration changes are looking good, then you can swap your staging and production environments. And so underneath the hood, when you swap those slots, App Service will scale out your new staging environment before it goes into production. So that way you're ready to meet any production workloads with that new build. Then once you've deployed your code onto App Service and you've set up deployment slots, you can then secure your site on App Service with all of the networking features that Azure offers. So you can deploy your web app into a virtual network, and that will secure the connections between the Azure web app and other resources, such as a database, a cache, or a messaging service. And then you can also use ExpressRoute, which we're seeing here in the bottom of the screen, and that allows you to connect to on-premises resources. Since we're talking about migrating and modernization, you might have some dependencies on-prem that you still need to connect to. So Azure has networking features to enable that. Then once you've set up private endpoints, you can use that feature to isolate your application from the public internet. And that's great for internal-facing applications if you don't want your resources being accessible to the public internet and you only want them facing internally. And then there's other great features too in Azure networking, like Azure Front Door and Azure CDN, to give yourself more points of presence for your Azure web app. Then once you've set up networking and secured your site, you can also set up rules to automatically scale your deployment vertically or horizontally. So you can scale up to larger VM sizes, or you can scale out horizontally to more VMs. And you can set up those rules based on a whole bunch of different metrics, like request counts, CPU or memory consumption, or simply by the time of day if you wanted to scale up during business hours and scale back down during off hours. Now, when you're scaled out to multiple instances, App Service has a feature called Health Check, and this will ping all of your independent instances. And if any of them are unhealthy, they'll be removed from the load balancer. So that way they're not responding to end user requests. And if they become healthy again, then they'll be brought into the load balancer to continue serving requests. Then when you're scaled out to multiple instances handling millions of requests, monitoring becomes very important to monitor all of that infrastructure. So thankfully, App Service integrates directly with Azure Monitor, which is the Azure native monitoring solution, and it provides a turnkey monitoring solution for your Java applications. So that means there are no code changes required. All you have to do is enable application insights from the Azure portal or the CLI, and then the service will attach the monitoring agent to your application for you, and the metrics will begin flowing into application insights. When this is enabled, you can use application insights to watch live metrics, which is what we're seeing here on the screen. And you can also view an application map of your entire deployment. And then you can set up alerts for scenarios like slow or failing requests and get a text or an email alert. And then you can use application insights to diagnose and solve that problem. So talking about Java on App Service, we've actually had support for Java since 2014. You can deploy applications with an embedded servlet, so something like Spring Boot or Quarkus or MicroProfile or anything that runs as a .jar application generally. And you can deploy that to Java 8, 11, or 17, and we use the Microsoft build of the OpenJDK. On the other hand, if your application runs on top of Tomcat, we do have a managed Tomcat runtime where you can deploy your WAR applications. Over the years, though, we've heard from our customers that they wanted a similar hosting option for their Java EE applications as well. And so that's why we've partnered with Red Hat to offer JBoss EAP on top of the Azure App Service platform. So this means that you get all of the features I mentioned earlier, like easy deployment APIs, networking features, auto scaling, monitoring, and everything else that's offered as part of App Service is also available for JBoss EAP on App Service, since it's offered on top of the platform. And even better, this is a jointly supported offering from Red Hat and Azure. So that means you get full stack technical support from both companies. If you run into a problem or you have a question, you can submit a support case with either company, and then behind the scenes, the support engineers from Red Hat and Azure will collaborate to resolve your case. And this is by default. All JBoss EAP apps on App Service are automatically enrolled into the joint support program. And you don't need to secure a separate support entitlement from Red Hat. So without further ado, I'm going to hand it off now to James Faulkner to walk us through an exciting demo of JBoss EAP on Azure App Service.
All right, thank you very much, Jason. Fantastic to see all those awesome features, apply to Java EE, Jakarta EE applications that have been in production for 2 decades. Really, and having the ability to move those easily to the cloud with Azure is a nice offering. This is the new offering that we launched last year, JBoss EAP on Azure App Service. So what I'm going to demo today is taking an existing production application on-prem and migrating it to JBoss EAP on Azure App Service, and then exploring a few of the integrations that we've also worked on with in partnership with Microsoft to really enable a traditional Jakarta EE application to take advantage of the modalities of cloud deployment, cloud development, and the scalability and reliability of Azure. So I'm going to start here on the Azure portal, and this is where you create new web apps. Brian earlier demoed creating a generic Java web app. We're going to go ahead and create a JBoss EAP web app by clicking Create Resource. Same thing here, click Create under Web App. And under here is where you enter the resource name, the resource group name, the web app name, and some other information. There's also a new experience you can try out. I'm going to use it today because my existing Jakarta EE application relies on a database in addition to the business logic. So I'm going to use this experience to create the database and the web app very quickly. So you can pick a new resource group. I'll just call it JHF Test. Give it a name, JHF Test Web App, and then you'll pick a runtime stack. Now, in this case, Josh mentioned Java 17 is the only way to go. Well, it's currently the only way to go for about 10% of the Java ecosystem. We're happy to see the increase, the numbers increasing on Java 17. We are adding support for Java 17 in the Red Hat stack as well. But the vast majority of our customers are on either 8 or 11. So I'm going to go with 11 here, and then here I can pick JBoss EAP 7, and that's really the only difference between deploying a generic EAP or generic Java app versus a Jakarta EE app with EAP 7. I can also specify the database name here. It'll automatically create a flexible server using Postgres. I've already created this. I've actually created a number of different environments, cooking show style, since we have a limited amount of time. So I would normally click Review and Create, and then go ahead and create that. So what that's going to give me is a web app running JBoss EAP. So I have this under JHF Web App 1. So this is my first web app. It doesn't have any actual application deployed to it, but it is a running web app instance. You can see here if I access the home page, there's a default landing page. So this is where we're going to deploy our application. So the application that we have running in production today is over here, and I've loaded it into my VS Code IDE. This is actually a WebLogic application. You can see several of the classes use proprietary WebLogic APIs. To run this with JBoss EAP and Jakarta EE on Azure App Service, we need to move away from these APIs and move to the more standard Jakarta EE APIs. And so what Red Hat has created over the last 20 years of working with our customers is a toolkit, a tool set of reusable rules that can automatically analyze your source code and identify issues like proprietary use of APIs or things that aren't cloud ready, for example, hard-coded IP addresses, local file system access, things like that. This tool is called the Migration Toolkit for applications. We have a number of other toolkits for migrating containers and virtual machines as well. This particular application Migration Toolkit also has a VS Code extension, so I've loaded that into my IDE here, and I'm going to go ahead and run the analysis. So I'll configure my analysis with a target of EAP 7, which is the version of EAP that's supported on Azure App Service. And then under the source, I will pick WebLogic here. I've also entered the source code folder in which the source code exists, so I can simply right-click and say run here, and it will take about 30 seconds to run. And so what it's actually doing is it's taking those rules that we've identified. Over the past decade, we continue to identify new rules where we found customers migrating applications. We've encoded those into this tooling. So this tooling is applying that rule set based on my source and target to my source code, and it's going to generate a report that says, okay, here you're using non-standard APIs. Here you're using local file system access. Depending on the source and target, it applies a different set of rules for analyzing and allowing you to do a migration. Now, this tool is useful for an application, but is really useful when you're doing 100 or maybe 1,000 applications, and you need to know the relative level of difficulty of migrating these applications to the cloud, so that you can, say, assign your junior engineers to the easier applications and assign your more experienced engineers to the more difficult migrations. So using this tool, you can do that analysis and assessment of your applications and kind of get a really great idea of how long a migration is going to take and how hard it's going to be. So I've opened the report here. Let me open it up in my browser here. If I click here, so this is the report that gets generated, and you can see it assigns this thing called story points. These are the relative level of difficulty. So if I had multiple applications, you'd have multiple apps listed here with the different story points. But this one happens to have 11. Click on the name of the app, and I can get more detailed information, class by class and package by package of what happened. If I click on the issues tab, I can see the exact issues that it found. For example, it found the usage of the WebLogic proprietary logger in this particular class, in this particular line, and it kind of gives you guidance as to how to fix that. So this is a relatively easy one. There's a few other issues that it found in here. I'm not going to go through them in the interest of time, but what I will do is fix the application. So I'm going to go back, and you can see in the IDE, it kind of shows you, if I click on Startup Listener here, you can see one of the other issues that it found, which is a proprietary use of non-standard application lifecycle events. So I'm going to go ahead and fix that. It's a pretty simple fix. I'll just paste the code in here, and basically you can see the diffs here in Startup Listener, where it replaced the WebLogic APIs with the standard Java X, now Jakarta packaging names, and then changed the annotations to match that. So very easy to fix that file. There's one other file I need to fix real quick, which also uses a logging API that's not Java EE standard or Jakarta EE standard. That's in the promo service file. So I'll go over to the promo service file. You can see it's also marked here. So I'll just fix that, and bam. So I've got my application now migrated. So if I head back over to the tool and rerun it, we should hopefully get a 0 for the value. Again, this migration toolkit is really useful for a handful of applications where you really need to get a good sense of how difficult a migration is going to be, what's in your applications on your corporate applications. It also is extensible, so that if you find a specific use of some API or specific pattern in your applications at your company, you can encode that as a rule. You can use that in your CI pipelines to check the progress of a migration, or you can even contribute those upstream if they're applicable to the larger Java ecosystem. So this should be complete here in a few moments, and if we reload our the report, once it's done, hopefully we'll have a 0 here. Let's see how close we get. Finalizing, and drum roll.
I wish I had a soundboard.
Okay, so let me open the report back up in my browser here. Go back over here, reload, and I have 3. So I missed something. What did I miss here? Oh yeah, I forgot to delete the. There was a specific WebLogic EJB jar.xml file specifying the transaction timeout. That's actually handled in code now in the application, so I'm not going to worry about that. JBoss EAP won't read that file. We'll just go ahead and assume that I just removed that file, and it will then be correct. So with my application migrated, I'll just go ahead and build it just to make sure that I didn't make something I shouldn't have. Yeah, so it looks like it's done. or will be done here now. So another nice thing about Azure App Services has a number of extensions and plugins that Jason mentioned. One of them is in the Azure plugin for VS Code. So I can actually load my, I can see my web apps here. I have JHF web app 123. I'm going to basically deploy my newly created web app, my WAR file, to this web app, and it will go off and deploy that automatically through the plugin, and hit deploy. And once it starts, so I've already deployed it. So it'll build it, and then it'll automatically deploy that WAR file. We're not going to wait for that because I've already deployed it into my second web app here. So I'm going to go back to my web apps to JHF web app 2. So this is what you get once you deploy the application, whether you do it through the Maven plugin or through a GitHub action, which we'll do later, or through Azure or through the VS Code plugin. It will get deployed and it will get automatically brought up. And so here's my new application. This is a retail store application, very similar API to any other retail stores you've seen on the internet. It's got a number of different services using standard Jakarta EE APIs like EJBs and CDI and REST and lots of stuff like that. So this application also, as I mentioned, uses a database. And so as part of my application, if I go back to my source files, you can see that integration there. What we have is a set of JBoss CLI commands. This is a JBoss ships with a CLI that lets you automatically create data sources. We've automated this so that it's repeatable, and every time our app service starts or restarts, this database driver and data source is there for the application to use. And you'll notice it has a number of variables there, so I don't have to re-specify them for every different environment. We use environment variables there, which are then passed from app service. Let me show you that. So under configuration, those variables are declared here. So depending on which environment you are, you'll have the different values here, which then get replaced. And so the application can get connected to its Postgres database automatically. So that's kind of nice. So now with my application up and running, now I want to turn my attention to CI. And we have about 4 minutes left, so I'm going to go kind of fast here. So what we want to do is configure this for GitHub Actions so that every time a change is made, it'll automatically deploy those. So I'm going to go to Deployment Center. I'm going to link this with my GitHub source code. So I'll select GitHub here. I'll choose my organization, which is me. My repository is going to be the workshop repository, workshop. And I'll choose a branch of just choose main. And it automatically detects all the things, Java 11, JBoss EAP. You can get preview. You can see what it's going to create. It's going to create the same thing that Brian created earlier, except this is specifically going to use the Azure Web App Service integration with GitHub Actions to deploy that. So I'll go ahead and click Save. And so what that's going to do is create a GitHub Actions runner file in my source repository automatically for me. It's also going to set up the credentials so that it can easily keep those secret, using the same mechanism Brian showed earlier with GitHub Secrets, and it's going to automatically push that every time I make a change. So if I head over to the actual repository, you can see here, if you go over to Actions, you'll see a new action has started to run, and it will build and then deploy that all the way to my app service. So very easy to set that up. So the last thing I want to show is the metrics and observability integration with Application Insights. So heading back over to the code, Application Insights gives you out-of-the-box stuff with Java, but it also allows you to do customized metrics. So, for example, in my product service, say I want to add a mechanism to automatically expose a metric of how many times an API has been accessed via micrometer. So I'll create a counter. Counter equals metrics.counter, give it a name, get product counter. And then I will actually use that counter. I need to import the metrics class here, very easy to do. And then under my get products, I'll just say counter.increment. Go ahead and rebuild that and then redeploy that. If I open my terminal, Maven clean package. So just to make sure it kind of builds here. So what I'm going to do now is actually commit this code to my repository. And what that should do is kick off another build, deploy this application out. So if I go over to my source repository, add counter, and yes, I will commit it. sync changes. This is going to push that code up to my repository. So if I head back to my browser, get over to my repository, you'll see a new action beginning. So we're not going to wait for that to complete as well. I've created a third environment which has this already deployed. So if I head back here, go to Web App 3, you can see I still have my application up and running with Web App 3, but I can also do things like in the where is it? It's hard to find sometimes. Application insights. So if I click on view application insights data, I can get, like I said, default kind of server response, failed requests, availability status, but I can also get metrics. So if I head over to the metrics here, and I can choose to select default JVM metrics or OS metrics, but I can also hopefully find my my custom counter here, this get product counter. You can see I've got a thing running in the background that's accessing this. So you can automatically see that. You can also do things like look at the application map to see your application. In this case, it's a single application pointing to a single database, but you can imagine, if you had a more complex application with multiple components, you can kind of identify that and visualize that. You can also get logs and look at, SQL queries and things like that to identify some of the challenges that you may have. So you can see some of the SQL calls that have been made here, like this one here. Kind of shows the graph of a distributed graph of these calls that are being made within my application. So very powerful, very easy integration, very easy to take an application in production on premise today, move it to the cloud, shut down your data center, and still keep running with Jakarta EE and JBoss EAP. So that's it. I'll pause here. Yeah.
Flawless. The demo gods are really in our favor today, huh?
Yeah.
So before we wrap up, I've got a couple closing slides here. Perfect. There we go. So James just mentioned you can move your applications to the cloud very easily. Along those lines, we've recently announced support for clustering on JBoss EAP on App Service. So this means if you have applications which use features like stateful session beans, transaction coordination, high availability, or any other EE features which require worker-to-worker communication, you can now run those applications on App Service without refactoring or removing those features. It's very easy to set up. You just have to join your Azure web app to a virtual network, like we're showing here in the diagram. And then when you scale out horizontally to more instances, those workers will communicate over the virtual network. Now, we went over a lot of content today, so go ahead and check out these resources. The first QR code on top is a link to the JBoss on Azure module, which we're seeing here on the screen. And then down below is a demo that you can go through for deploying a clustered application onto Azure App Service. So in that demo, it gives you an ARM template and instructions to deploy all of the infrastructure. So all you need is an Azure subscription and Java installed locally. Thank you so much for watching today. If you want to reach out or have questions on anything we talked about in the session today, you can reach us at that email address. And thanks again. Have a nice day.
Thank you.
All right, thank you so much, folks, for awesome demo. James, you surprised me. I was in shock.
I thought you were surprised by my Oompa Loompa face. I don't know. I have no idea why I'm so red. Oddity.
No, I thought it was amazing because I've never seen that kind of demo, that kind of tool before. I heard about the toolkit for assessment and migration, but I never saw that integration level, like even like within Visual Studio Code, for example, the things that you showed. So that was pretty cool. Thanks for the demo.